As you know, Matlab has many built-in mathematical functions. Some examples are sine, the natural exponential function, the natural log. So we've seen how to graph functions as follows. Here I'm going to graph the sine and the cosine and the natural log all in the same figure. To do that, I use three built-in functions: sine, cosine, and log. Now it turns out that it's often useful to define a variable referring to a function. Every computer language has to define some mechanism for doing this. In Matlab, it turns out that we use the operator to create what's called a function handle. In what follows, I'm going to explain how to do this. But first I want to point out that you can't do this. You can't simply say f equals sin. The reason is that sin is not a value that can be assigned to a variable. When Matlab parses this statement, f equals sin, it starts with the right-hand side, and it tries to evaluate the sine function, and it can't do that because there's no input. So you see the error message says, error using sine, not enough input arguments. What we want to do is accomplished as follows. We use the operator, we say f equals @sine. What this does is assign a handle or a reference to the sine function to the variable f. Now we can use f in place of sine. So for instance, I can type f of pi, and that's the same as the sine of pi. I could plot x comma f of x, and what I get is a graph of the sine function. We can also use the operator to define new functions. Let me begin by clearing all of my variables. And now suppose I want to define the following function, f of x equals 1 over 1 plus x squared. This syntax doesn't work, but Matlab provides a mechanism that will allow me to define a function. The correct syntax looks like this. The operator tells Matlab that I'm defining a new function. Matlab calls this kind of function an anonymous function. To Matlab, that simply means that the function is not associated with the program file. The parentheses x tells Matlab that there's a single input variable, and that variable is called x in the following formula. And then the formula 1 over 1 plus x squared defines f of x. So what can I do now with f? Well, I could evaluate f. So f of 0 is 1, f of 2 is 1/5, etc. I could plot f. So let me first create an x vector, say from -5 to 5. Let me plot x f of x. Whoops, I made a mistake. The mistake is that I forgot to vectorize my formula for f. So let's recall my definition of f. And I want to go back and use the vectorized versions of division and exponentiation. And now let me try my plot command again. There's the graph of f of x. I could use the operator to define a function of two variables. Let's say 1 plus 2 times x squared plus y squared. And then I could evaluate this function like so. Instead of using the operator, we can define a function in an M file. We generally choose this option if the function is not defined by a simple formula. I want to show you an example, and I'm going to start by changing my current folder. So here's the folder that I want to use for files associated with this module. Now here's the example I'm going to do. I'm going to define f of x to be the sum of the positive integers less than or equal to x. Matlab provides a function called floor that computes the largest integer less than or equal to x, and I'm going to need to use this function floor. So for example, the floor of pi is 3. The floor of, say, 101.5 should be 101. The floor of 101 itself should also be 101, etc. And I'm now going to show you how to create a function M file. So I begin by opening a new file. I use the Command N shortcut. You could also go to the File menu to create this new file. Now a function has inputs and outputs. The first line of the function file has to name the function. It has to tell what the inputs are, and it has to tell what the outputs are. It also has to start with the keyword function. So here's how I write the first line. I'm going to call this function myf. It's going to have one input and one output. One input called x and one output called y. Now remember, I want to sum the integers from 1 up to x, stopping at the largest integer less than or equal to x. So the first thing I'll do is define n to be the floor of x. I'll then set y equal to 0. Y is going to be the output. For I equals 1 up to n, I set y equal to y plus I, And that's it. Now I save my file. Notice that Matlab automatically wants to call the file myf.m because I named the function myf. So I just choose save. Now I've defined my function. I would like to point out though that this function is not vectorized, so I would not be able to easily use this function to plot myf, for instance. But I have defined myf. I can now evaluate it. Myf of 1 is 1. Myf of pi would be 6. Why is it 6? Because the largest integer less than or equal to pi is 3. So myf of pi would be 1 plus 2 plus 3, which is 6. Myf of 32.5 is 528. Myf of 32 should have the same value. Or it would if I spelled myf correctly. Here's a very important point. You can pass one function as input to another function using a function handle. To demonstrate this, I'll create the function whose value is the sum from I equals 1 to n of f of I. Both the integer n and the function f will be input to the function, and I'm going to call that function mySumF. So I'll open a new file. I'll create a function. It has one output. It's called mySumF. It has two inputs, which are f and n. Remember that f is a function that I'm going to input to mySumF, and n is an integer. To do the calculation, I set y equals 0. Then for I equals 1 to n, I replace y by y plus f of I, and that's all. So I save my function by pressing Command S. Again, Matlab will choose a default file name based on the name of my function. So Matlab is going to call the function mySumF.m, which is what I want. For an example, let's calculate the sum from I equals 1 to 10 of the sine of I. I'm going to start by demonstrating a common mistake. You might think I would call the function mySumF like this, but I did not pass the sine function correctly. Here's the correct way to do it. mySumF of @sine, 10. So what I'm doing is creating a function handle referring to the function sine and passing that to mySumF. And there's the value. As another example, I'll create a new function and pass it to mySumF. F is going to be the function f of x equals 1 over x. Notice that I did vectorize the function, although I'm not going to use that feature now. Now I'll compute the sum from I equals 1 to 100 of f of I. And there's the result. A few more points about function M files. First, let me show you how to define a function with multiple outputs. As an example, let's suppose that f of x equals x cubed, and I want to define a function that returns both f of x and f prime of x for a given x. So here's how I create the function. Multiple outputs are listed between square brackets, like so. I'll call this function myF1. The input is x. The output fx is x cubed. The output dfx is 3 times x squared. I save this, choose the default name, and now I could say compute myF1 of 2. Notice that when I invoke the function like that, I only get the first output. If I actually want both outputs, I have to ask for them. Now let me remind you that the what command will list the M files in the current directory. So I now have 6 M files in this directory. If I want to see the contents of any one of them, I can ask Matlab to type it. That works well if I have a very short function like this. Now I'd like to show you how you can incorporate a function that you write into the help system. At this moment, if I type help mySumF, I'm told that there is no help found for mySumF. But suppose I go to the editor and I open mySumF, and I put a block of comments here. Comments in Matlab are lines that begin with the % symbol, and the first block of comments in an M file will be displayed when you type help followed by the name of that M file. So let me add some appropriate comments here. Okay, so what I've done is added a block of comments. The first line gives a brief summary of what this function does, and then I have details about how to call the function, what the inputs mean, and what the output is. Let me save this file as I've modified it. Now if I type help mySumF, I see those comments. Also, if I type help mfiles, first of all, I learned that there are two folders called mfiles as part of the Matlab path, and we'll talk about the Matlab path later. I'll just focus here on my folder called mfiles. I showed you earlier that there are 6 mfiles in this folder. However, only one of them has a help block. For that function, which is mySumF, that first line, the summary line, is displayed when I type help followed by the name of the folder. If I had defined a help block for all 6 functions, then there would be 6 lines here, giving the summary comment for each function. One last point about scripts and functions. Remember that Matlab has the concept of a current folder. This folder is where Matlab will look for any program files that you reference. Let's suppose I quit Matlab and restart it. On my system, when I first start Matlab, the current folder is set to this Matlab folder under the Documents directory. Now the mfiles I wrote before are stored in my mfiles folder. So if I try to reference one of those mfiles, Matlab's unable to find it. If I were to change the current folder to my mfiles folder, then I can use mySumF. This is a common mistake when using Matlab, writing an mfile and trying to reference it when that mfile is not found in the current folder. In that situation, either you need to move the mfile to the current folder or change the current folder to the folder where your mfile is found.